Welcome back, guys. This is Legit Lee back again with another tutorial video. I'm super excited about this one, guys, so don't mind me if I start sounding kind of crazy, but right now I've been working on this project for the last, I want to say, about a month now, and that's in between all my other projects, but this one is gonna be a really serious one because it should be able to help generate some funds to my channel since I'm not being paid by YouTube or anybody. But I wanted to give this information out to you guys so you guys can kind of make a good, I guess, a scenario or a decision really on your part to find out what battery you need and what you're really trying to do with your ESP32. So today's video is going to be based around that, the ESP32 microprocessing board. I'm using it currently to develop my own firmware, as you can see on the screen right here. So we have a Honda Grom firmware that I designed, and I am going to be using this for the Honda Grom. It's called Grom Control, and I do have an app being developed as we speak, and I did do all the programming myself, no help from anyone, and it's a super simple program, but it's the wiring, everything takes place. I have to make my own wiring harness and everything, but I will be selling this soon as a kit. But I want to talk about the main brain of the computer of this whole setup. So the ESP32 is going to be able to use a smartphone. So at the moment, for sure, an Android. I don't know about iPhones just yet, so I can't guarantee that at the moment. But for sure, a Android phone. And right now what I want to talk about is power management. So the ESP32 is doing a remote start system is what I'm making, and it needs to be able to be powered on basically forever. And obviously if you live in winter climates, or even here in Florida where I'm at, we have rain. Up north they have snow during the winter, so you may not want to have your ESP32 killing your bike battery while you're not actually using it. So if it rains out here, you're going to have your bike sitting up like a hurricane or something. So if you're lucky, you may not leave your bike sitting for longer than like a week or something, right? So but during that whole time, the brain or the computer that is connecting to your phone to actually remote start the bike up is actually still on, draining power, and you don't want your battery to die on your main battery. So I did add a separate battery that is a LiPo battery, as you can see here. And what that is a small little battery that you can charge up and be able to use. It charges quick and it stays charged for a long time, and it's small, compact. You can get different sizes. They use them for drones and all kind of different stuff out here, so they're really available for anybody. The bigger the battery you have, the longer it'll last, but then the fatter it is, so you may need to figure out your compensation for storage inside the bike. Currently mine is an 8,000 milliamp hour battery, so theoretically I did some calculations and it should last actually 3,333 days before it actually dies technically. But I went on a little vacation over a weekend and came back and the battery was dead. So I had to rethink this whole process because I didn't want that same thing to happen to you guys. So there is separate batteries. You have your main regular motorcycle battery that powers the bike, and then you have a LiPo battery that powers just the board to control your smartphone and the bike. So that main battery we're not even messing with. Exactly anyway, as long as the bike is running or whatever. But when the bike is off, the battery from your main battery is not going to power the chip. Your LiPo battery will do so. So the reason why I'm making this video is because we want to talk about how to use low Bluetooth energy. So originally, whenever you get an ESP32, what you would wind up doing is getting it all set up for an Arduino IDE program like this, and then you would go to just basically getting it set to where you have your COM port, right? And then you pretty much leave most of this stuff alone. As long as everything is communicating right and you know where your COM port is, then you would just connect it, make sure it's connected, then you would upload the sketch to the board. Well, when it comes to this, we're wanting to use as less power as possible, and since my sketch doesn't require a whole lot of processing, that's where the differences come in. So your ESP32 natively at default comes out to 240 megahertz per second. So what that means is the CPU or processor that is running your controller is running at the highest basically that it has, which is fine because usually most people want to have the fastest, and I would have left it that way if I didn't use Bluetooth or a battery. Basically, if I wasn't using a battery, I would use the fastest it can run, because then your everything would just seem seamless. But since my sketch here, or my firmware that I am writing and developing here, doesn't require much, it doesn't have a bunch of tabs, it's not like I'm running a Marlin firmware or like Gerbil or some kind of CNC. There's not a bunch of tabs. It's not using a lot. It doesn't have to do a whole bunch of processing information. All it needs to do really is receive data from the Bluetooth to send out a signal to activate my relays for the most part. And then, you know, obviously I have a wiring diagram set up and wiring harness that I had to develop for this GROM control system here. But besides that, the main information is pretty minuscule, so it doesn't require a lot of processing power to do so, which is great for my scenario. So if you look here, when I talked about when you first get everything set up, usually your board frequency is at 240 megahertz. But you can see here it says Wi-Fi and BT for Bluetooth. All these right here have the ability to, you can bring down the frequency information. So the lower you bring it down, the more power you should be able to save, because it's not having to generate that much information. So at 240, we're going to do a demonstration here. I'm going to have another screen here in a moment, show you guys. I have a USB tester that shows you how much amps are being drawn and all that good information. So this video is going to get kind of technical, but if you guys are into the ESP32 and you want to learn how to save as much power as possible for any kind of application that you have, and you want to be able to connect your smartphone to it still, then this is going to be a very good and detailed video for you. So if you guys haven't already, definitely consider subscribing to the channel. I do tutorials like this and do a bunch of DIY projects that have to do with Arduinos and microprocessors and a bunch of different things that you guys will actually probably enjoy and probably already have thought about doing previously. But anyway, so we're gonna stick at the 240 hertz, so that way you guys can see that of what I'm talking about here. And so we're gonna stick at the basis. I have my Arduino's COM port set up for COM3. And now all we have to do is just upload the sketch, right? So I'm uploading a sketch now. It's going to take a second. Then you have to press a button. I have that ESP32 where it has the button that you have to press when it starts to actually upload the code. So when it says connecting, for instance, I'll show you guys that down here in a minute as soon as it pops up. Now we're using Dev Kit 1 basically for the board that I have. Come on, hurry up. It's just taking a second. There it goes. Okay, so see connecting, then you have to click this little boot button for a few seconds. Then it's connected, then you can release the button, and now it's writing the data information to the board. So now once that happens, the data will be done, and then it'll say hard resetting via RTS pin. So that means it's resetting the board so you don't have to do anything else. Now the board should have my code on there and it should be working without any issues. So now what we're going to do is actually start showing you what the power usage is for the 240 megahertz. Alright guys, so now that we have everything plugged up, I got a black web generic USB charger from Walmart. And we have this USB digital tester, so it gives you all the information you need. Right now you can see it saying 5 volts is coming in. We're not draining anything out yet for amperage or wattage or anything like that. because we don't have it plugged in just yet, but I am going to plug it in now so you guys can see. So with it plugged in, it's reading 7 to 14 amps. Like it fluctuates, I guess. Well, obviously you guys can see that it's reading 7 to 14. Now if I connect my phone to the app, to the actual ESP, you can see here it says connected. If I go ahead and switch some buttons on, you guys can see that we're going to be generating more power because the output is going to draw more current in amps, basically. So if I turn on 2, now you can see it's drawing 28. So if I shut that off, now we're back down to 14 to 7-ish. So again, if I turn them on, then we're drawing 28 milliamps, or 2800 milliamps to 21, fluctuating 25-ish. So with that being said, I just wanted to show you guys that right now we have basically like 70 milliamps, I guess, because it's 0.07 and that's with 240 megahertz being on here. So now we're going to test out a different version. Okay, so we have the ESP32 plugged back in, and you can see here we're back on COM 3 still. Now, from being normally at 240 megahertz, we're going to drop down to 160. Still gives us Wi-Fi and Bluetooth information. So if I set it to that, and then we go ahead and upload the sketch again, because each time that you set the frequency, you're going to have to upload the sketch, because the sketch is telling the chip to use 160 megahertz now instead of the 240 that we uploaded earlier. So now that we're waiting, it'll take just a second. It doesn't take too long, that's why I'm not going to pause the video or try to speed it up, because there's really just no point. But now that it's done with that, we can go ahead and hit the boot button, so that way we can get it to actually start uploading the sketch. Now it's writing the information to the chip onto the motherboard, basically. And there we go, it's finished. So now we're going to show you the voltage coming out of this. Okay, so now we're going to start plugging this in. So we're still at 0, you can see here, at basically 5.1 volts. It's a little finicky. I guess that port's weird. There we go. Or maybe I gotta push it all the way in. I don't know. It's weird. Maybe it's this. It could be that. I think it was that. Okay. Now, we plug it in. Now you can see it is drawing 0.5. So from 7 down to 5, it probably fluctuates to like maybe 8 or so. We'll see here. I'm gonna go ahead and get my app connected. See, now it went to 12, so it's fluctuating, and it's because it's running code and checking for, you know, connection to the Bluetooth. So now that we have it plugged in, we can go ahead and turn on 2. Now we're running 25-ish. Remember, I believe it was like 28 just a second ago, but see, it went down to 19. So 25 to 19 for just two of the relays on. And we're still at 12. Then it's probably going to drop down to, what was that? 5 to 4. And that's still connected. It's still connected. So if I still hit that button, you know, now we're still doing that. So around 5 is where we're looking at. 4 to 5. And that should be 50, I guess, 50 to 40 milliamps if it's in hundreds. I'm not sure what the decimal place is on this for sure, but if that's 100, then that's got to be 50-ish. So now that we did that, let's go ahead and unplug this, and now we're going to try the last one of our options, which is the 880 megahertz. Okay guys, so now we are going to try 80 megahertz. So it is connected. So if we go down to megahertz here and do 80, that's the last one we can do. Just make sure you guys can see that. That's the last one you can do with Wi-Fi and Bluetooth enabled. But if you're not using Wi-Fi or Bluetooth and you want to use say a button, push button or something of that sort, then you have all these other megahertz you can try, which obviously is going to run the CPU slower, and then on top of that you're going to be saving more power, but it just depends on what it is that you're trying to do. 80 megahertz is probably way overkill for my project anyway, but there's no one lower than that with Wi-Fi and Bluetooth. Really, I just need a Bluetooth. I don't even need Wi-Fi, but it's a compact combo thing, so you can't really change that. It's off by default unless you're activating Wi-Fi. So anyway, so we have it set now. We're going to go ahead and upload the code again. And take a second for this to do what it needs to do. I'm sorry if it's noisy in the background, guys. I do have a AC unit running inside of my office, and that's just because it's hot as heck out here in Florida, and there's nothing else I could do about that. But now that it's uploading, let's go ahead and hit that boot button one last time, and then there we have it. It is now writing the new code. Well, really it's the same code, just writing the new frequency clock, which is 80 megahertz, which is the lowest one and should be the most power efficient version. So now we're going to show you guys what it looks like with it plugged up and how much amps this one's running. Okay, so we have the 80 megahertz one actually uploaded, so that is the lowest, most power efficient for Bluetooth and Wi-Fi. So if I plug this in now, it's using 4. So before it was 5 to 4, now it for sure is 4, and that's basically 40 milliamps, I guess, which still is nothing, and it's jumping from 4 to 11. So it's not a lot of milliamps that we are saving, but it still is significant compared to using 5 to 12. Now we're 4 to 11-ish that you guys can see there. So that is what I was trying to discuss and talk to you guys about. So if you need Bluetooth and Wi-Fi and your code doesn't have a lot of coding or processing needing to be processed, then you can bring down your frequency clock to get more power out of your ESP32. And just for demonstration purposes, I'll go ahead and launch the app one last time here for you. So we're going to go ahead and get this connected. You can see right there it says connected, all good. So now if I bring this little guy in here a little bit so you guys can see the light on. If I hit the buttons, let's get out of that, and we just hit 1. There you go. And we're running 24 instead of that 25 to 26. And now we're at 18. So still pretty significant, and still 24, so it seems pretty accurate for that 24. If you're running more switches, obviously, then you're going to be draining more power. I can demonstrate that here. So if I have, this is 5 switches on, we're at a little above a half an amp, and then it drops down. I think it's just because the output, it's generating current for just that one time that you're pressing these buttons, so it shouldn't go more than like 55-ish, I hope, of milliamps, which is a little more than an amp and, you know, and 5 or whatever, half an amp, 55. And obviously you can see it drops down to like 45, 46, and then once I shut everything off, then it goes back down. Still not using a lot of power, and this won't be necessary for the bike anyway. Really, the main thing is for the standby state, which is this right here with no switches on. Because for my application, I'm running a motorcycle basically off of this. So the motorcycle, while it's on, it's going to be charging via the stator that's charging normally the motorcycle's battery. So the motorcycle battery and the LiPo battery that will be connected to this circuit is going to be charged from the bike. So I don't need to worry about any of those switches being on, draining power while it's in standby, because the bike doesn't need to be on at that point. And when the switches are on, the bike should be running and charging the battery. So the only thing I really needed to worry about is the standby time where the bike is off and the battery is just constantly powering the chip, waiting to receive a signal from my cell phone to do the whole Bluetooth connectivity and turn the bike on. So with that being said, I am going to leave my stuff at 80 megahertz because that's what I need to have for the lowest possible power consumption. And you can see it jumps from 4 to 11, which is fine for me. I'm honestly not stressing that at all. And with it being able to do so at that amount of voltage, I should be getting a lot more power, or at least a longer duration of the chip being on without me having the bike on. So if I decided to sit the bike up for a week or even maybe a month, then I shouldn't have to worry about the battery that's powering this chip dying on me. And that's the reason why I'm making this video, so that way you guys can see the whole what Bluetooth power draw do you need for your project. If you need to run 240 megahertz, then you're going to be around, I want to say 7 to 10 milliamps, well 70, so you'll be at 100 to 70 milliamps on a regular basis. And then if you're using 160 megahertz, then you're going to be at 50 to 120, so like the 70 to like 110, 120 something. So that it varies depending on what it is that you're having the board and stuff do, but 80 megahertz is the lowest, obviously, and it runs a lot less power, so then you can save a lot on your battery, and it will extenuate your days where you don't have to worry about your battery dying for quite some time. So if you have something like you're on a farm, you have to check crops, but you don't need to do so until like every other month or something, then you can connect to your phone using a sensor that's connected to the ESP, and it's far out there and you don't want to have to run all the way down to the end of your farm where the sensor is at to check your stuff, then something like this would be beneficial for you. So I hope you guys liked the video. Please like, share, subscribe. Let me know what you guys think down in the comments below, and let me know what you guys are doing with these ESP32s and what this information would do to help you in your projects. I like to hear what you guys are making, and don't forget to let me know down in the comments below if you have a video for those specific projects as well. My name is Legit Lee. I will see you guys in the next video.